All right, in this unit, we are going to start learning about one of the most applicable concepts of geometry, which is perimeter and area. We're going to start by finding the circumference of circles and then find portions of the circumference of the circle. Maybe we don't want to go all the way around the circle. Maybe we only want to go part of the way around the circle. So circumference, by definition, is the distance around the circle. It's how much ribbon you would need to go around the plate. It's how much crust you would have on a piece of pizza. The distance around, not 360 degrees. That's the measure. We want to know the length, the distance, or the length around the circle. And that is found by using the formula C is equal to 2 times pi times the radius, or C is equal to pi times the diameter. They're the same equation because a diameter is 2 radiuses. Okay, so this is quick review. You've done this before. We have a circle. I want to know the distance around the circle. It has a radius of 5. The radius is from the center to the side. So you can use the 2 pi r formula. C is equal to 2 times pi times the radius. Now there are 2 ways you can leave your answer. You can leave them in exact form and you can leave them in approximate form. Exact form means we're going to multiply everything except for the pi. So we're going to do 2 times 5 and we get 10, and we leave it what we call in terms of pi. In terms of pi. If I say to leave it in terms of pi, it means that you will leave pi in your answer. That is exact. Okay, pi has a lot of decimals, and so we don't want to use those decimals. We don't want to round. We want to incorporate and keep all of those decimals in the answer as much as we can. And so not multiplying the pi out is actually leaving exact, even though it doesn't feel like it. And then approximate, that little squiggly equal sign, approximate is using the pi key. And so you would do 10 pi, use the pi key, 10 pi, and you would get 31.4159. You can see this. I know this feels like this is not approximate. It feels like this is more exact. But the problem is there are more decimals out here that we can't see, and we're not going to use all the decimals. We're just going to round. We'll round to the nearest tenth. So that would be 31.4 meters. And since I didn't use the rest of the decimals, they are there. We're just not using them. So that's why it's not exact. We're saying it's about 31.4. This is approximate. Okay, so you need to know the difference between that. Circle AB is the diameter all the way across. So I put the measurement in the middle. You can use the circumference is equal to pi times the diameter. If you leave it exact, then it's just 20 pi. And if you get the approximate, you simply type in 20 pi on your calculator and get 62. It's about 62.8. In this case, it'd be 62.8 meters. So what if I give you the circumference and I want to find the radius and the diameter? All right, well, this is your radius. In the middle is your diameter. Your diameter is the distance all the way across. Use the same formula. Circumference is equal to 2 pi r, or circumference is equal to 16 pi, and then you have 2 pi r. One of the biggest things you have to remember is that pi is not a variable. It's a number. Okay, so when you divide, you would divide both sides by 2 pi. Divide both sides by 2 pi. Notice that the pi's cancel out, leave you with 16 over 2. These 2 pi's over here cancel out, and so it leaves you with the radius is equal to 8. If the radius is 8, then the diameter is 16. Now you could also look at it like this. C is equal to pi d. So the circumference was 16 pi, and then pi times the diameter. Pi is just a number, so divide both sides by pi. Cancels out, leaves you with the diameter is 16, and then the radius is 8. So you can solve it however you want. Now, what if I tell you that the circumference of a bicycle wheel is 69.115? Well, that is approximate. The pi has already been multiplied. What is the diameter of the wheel? Well, so then we go in and we do circumference is equal to pi d. Since I want diameter, let's use that equation. So 69.115 is equal to pi d. So we're going to divide by pi. So you would type that in, 69.115 divided by pi, and you get 21.9999999. So that's about as close as we can get to getting a diameter of 22 inches. If the diameter is 22 inches, then the radius must be 11 inches. Now, I do want to point something out just so you won't make this mistake. If you decide you want to use 2 pi r, you want to find the radius first, that's fine. But be sure that you divide by, when you type that in on your calculator, it would be 69.115 divided by 2 pi. You have to divide with it in parentheses, or if you want to, you can do it as a fraction, and then that way you won't make a mistake. 69.115 and then 2 pi in the denominator like that. Okay, notice that you get the same 11. But if you do 69.115 divided by 2 pi like that, you will not get the same answer. Okay, so, and that doesn't make any sense right there. There's no way that you can have a radius of 108.6 when the distance around the shape is 69.115. It doesn't make any sense. So be very careful that when you divide by 2 pi, up here it all canceled out, so it didn't really worry me, but I could have kept it and done 16 pi divided by 2 pi and let the calculator handle all the math. Just don't forget to divide by 2 pi in parentheses. Don't make that mistake, and always check and make sure that your answers make sense. Now, I mentioned that we were going to learn about what happens if we don't want to go all the way around the circle. What if I only want to go part of the way around the circle? That is called arc length. Now, we talked about arc measure in the last unit. That was how many degrees of the circle. That's your theta. Arc length is a portion of the length. It's a fractional part of the length. Okay, it is a fractional portion of the length around the circle. So maybe I don't want to put ribbon all the way around the plate. I only want to put ribbon around that much of the plate. Okay, now the difference is if I say arc measure is theta, that is an angle. It's measured in degrees. If I call it arc length, then I want a distance, a length, okay? That is the difference. Arc measure, if I ask for arc measure, I'm asking for theta, or the angle, okay, whatever the angle is called. I want the amount of rotation. So AB, remember we talked about this, that the angle is equal to, this theta is equal to the measure of the arc, AB. So if this was 60 degrees, this would be 60 degrees. But what I'm asking for is what is the length. The formula for that, we're going to use this as a proportion. There's two ways you can look at it, but we're going to look at it as a proportion to start. That it's this many degrees out of 360 degrees. That's my fractional part. Right? How many degrees? How many degrees am I rotating out of 360 degrees? If it's 90 degrees, then that would be a quarter of the circle. If it's 180 degrees, that would be half the circle. That's my fractional part. So theta over 360 is equal to, now this length, right, this piece, that L, that length right there is a portion of the whole distance around. It's a portion of the circumference. So it was this many degrees out of this many degrees. So it is this much length out of 2 pi r, or it might just shortcut it and say c, but we know that circumference is 2 pi r. So these are our fractional pieces, and they should be equal to each other. So it's this many degrees out of 360 degrees is equal to this partial distance around the circle divided by this entire distance around the circle. So let's look at some examples with this. I want to find the indicated measure. I want to show my answers as exact and round as to the nearest tenth. So the arc length of ACB. So ACB and CB. ACB, notice arc ACB is half a circle. Okay, so if I want to know the length of that arc, then it would be 180 degrees out of 360 degrees is equal to the length of the arc divided by the circumference. This is not the only way, so some of you may be able to start thinking about it like I'm going to show you how to type it in on the calculator, but it would be 2 times pi times radius. So the easiest thing to do here is to find this fraction, 180 divided by 360. Well, that's half a circle. We know that, half a circle. And then multiply that by the radius times 2. We're not going to multiply the pi. We're going to leave it in terms of pi. We're just going to skip it. Okay, don't forget it's still hanging there. So that would be 6 pi. Well, let's look. What's the distance all the way around the circle? Well, the distance all the way around the circle is 2 times pi times 6. That's 12 pi. Well, I only want to go halfway around the circle. So divide that by 2 and I get 6 pi. That's what's going on. Multiplying it by 1/2 or dividing it by 2. And then 6 times pi is 18.8 approximately, because we had to round. If you ever have to round, it's approximately. Now what if I want to go arc CB? Notice that arc CB is 1/4 of the way around the circle, 1/4 of the distance all the way around. So if we just look at it just in what makes sense, right, then the circumference we've already said was 12 pi. I'm going 1/4 of the distance around. I'm going to divide it by 4. That's 3 pi. That part we can do. We know what 1/4 is and what half is. But if we want to do it officially, right, then we would do 90 degrees out of 360 degrees is equal to the length of the arc divided by the distance all the way around. So take this, do it like this. Now you can cross multiply, but the scale factor is this fractional distance around. So 90 divided by 360 times 2, we're not going to multiply by pi, times 6. And you get 3, which is what we said earlier, right? It's just 2 different ways of thinking about it. This is all the way, 12 pi is all the way around the circle. I'm breaking it into 4 equal pieces, so I get 3 pi, or 90 over 360. Y'all look, 90 divided by 360 is 1/4. So 1/4 times 12 pi is 3 pi. 3 pi, actually, if we want to get a number, 3 pi is 9.4. And that's in centimeters because it is a length measurement. Now, this is easy, but when you start getting decimals that you don't know, right? We don't know what fractional part 97% or 97 degrees of 360 degrees is. So we just want to find the arc length of AB. I want to know the distance from here to here. It is 97 degrees, but how far is it? Okay, arc AB, the measure of arc AB is 97 degrees, but how long is the length? So it is 97 degrees out of 360 degrees is equal to the length of the arc, part over whole, 2 pi r. Part over whole equals part over whole. That's what we're doing. So you can cross multiply and divide by 360, or you can do the fractional part, 97 divided by 360 times 2, keep the pi, times 4. Okay? Now, notice this is not very pretty, right? So this would be 2.2 pi. And then, because I didn't multiply the pi, it's just that 97 over 360 is an ugly fraction. Okay, now I could math enter that back into a fraction, and that would be 97 over 45 pi. That 2.2 turned back into 97 over 45, and then you have that pi. If I can just multiply that by pi to get the actual estimated distance, it's 6.8. And that would be in feet because it is a length around. Okay. Now, the reason that I want you to understand how the equation works as proportions like we did up here, and not just always doing the fraction times the circumference, is because sometimes I'm going to give you the arc length. They use an S for arc length instead of an L. This one, I want the measure of AB. I want the measure of AB. That means I want the amount of degrees. I want theta. I want to know that arc. That's what I'm looking for. Okay, if I want the arc length, it will always say arc length. It might say S, but it will say arc length. So S, this is the arc length. In this case, this is where that part over whole proportion. Okay, so how much am I using of the circle in degrees over how much am I using in the circle in length? So theta degrees out of 360 degrees. I want to know this part, but this is always the whole degrees of the circle is equal to how far around the circle am I using? Okay, how far around the circle am I using? I'm using 15.87 feet out of the entire distance around the circle, 2 times pi times 7. Now in this case, you do need to cross multiply because you've got your variables, or you could do this division and then multiply it by 360. Okay, so in this case, I'm looking for the length, so I divide the angles, multiply by the whole side. This one, I'm looking for the angles, so I divide and I multiply by the whole angle. You can cross multiply and then divide, or you can divide and then cross multiply. It doesn't matter. However, if you're going to divide, remember to use parentheses. So you would type this in 15.87 divided by parentheses. I'm going to go ahead and use that pi since that's already been simplified. It's not in terms of pi. So 2 times pi times 7. So I'm going to do this divided by this, enter, times 360. You never want to round until the very end. So that would be 129.9. Oh, that's not 129.9 feet. It's 129.9 degrees. Okay, because we were looking for theta, right? You're looking for theta. So that's a mistake that you can make. So make sure you understand what it is you're looking for. Okay, now in this one, same thing, only this time I'm looking for C. I'm looking for the circumference. So instead of writing 2 pi r, I'm just going to use C because I don't want to know what the radius is. I want to know what the circumference is. I'm using 60 degrees out of 360 degrees. That fractional distance in the fractional measure of the angle should equal the fractional distance around the circle. 3.44 is how far, it's a distance, is how far I'm going around the circle out of the whole circle. Part over whole equals part over whole. Okay, cross multiply. This one is easier to cross multiply because you have your variable on the bottom, so you can handle this proportion however you see that you want to handle it. So you would have 360 times 3.44 divided by 60. Looks like that. And you would get that the circumference is 20.64. Now, one of the tricky things is recognizing when to keep the pi and when not to. If there's not a pi in the problem, then you're not going to leave pi in the answer. Okay? If you don't hit the pi, there was a pi in the problem and you didn't hit the pi key, then you keep the pi. Okay? If you hit the pi key, then don't keep the pi symbol. Okay? So just kind of, you have to keep up with that. So in words, let's look at what this looks like. The length of the arc of the circle is 12 pi. We're going to call that S or L. Has an 80-degree central angle, that's your theta associated. What is the radius of the circle? So ultimately then I'm going to take this and go one step further. I could find the radius, right? 20.64 is equal to 2 pi r or pi d. So we're going to go that next step here. Same process. So it was 80 degrees out of 360 degrees. So my equivalent fraction is my arc length. That's my part of the circle divided by my circumference. Now, I did pi d on purpose because I don't want to make a mistake when I divide by 2 and pi, right? That whole thing about dividing with parentheses. So sometimes it's easier just to find the diameter and then remember at the end to find the radius. Now, one thing you might notice is these pi's are going to cancel out anyway, and so you don't have to worry about it. When they are in the same fraction, they will cancel out and become 1. So now you can just cross multiply 360 times 12 divided by 80, and you get that the diameter is 54. But I didn't ask for the diameter, I asked for the radius. So the diameter is twice the radius, divide that by 2, and you get that the radius is 27 meters. Okay, so circumference is the distance all the way around, and arc length is the distance part of the way around. It is a fractional distance, and we compare the two fractions, the fractional part of the degrees and the fractional part of the distance around when the whole distance is the circumference, or 2 pi r or pi d.